talking about solving exponential and logarithmic equations, and we want to solve logarithmic equations by exponentiating both sides of the equation. This one on the left here, first thing we have is we want to use our properties of logs. We have a log base 4 and a log base 4, so what we can do is we can combine those together with one log using multiplication. So we can have the log base 4 of x plus 12 multiplied by x, and that is equal to 3. And then we can distribute inside the log there, and we get log base 4 of x squared plus 12x, and that is equal to 3. Now we have the log just on one side, and so now we can exponentiate both sides of the equation. That will help us get rid of this log base 4 over here. And we want to pick the value of 4 because then that will equal to 1. So we have 4 log base 4 of x squared plus 12x is equal to 4 to the third. And 4 log to the fourth is 1. So we are left with x squared plus 12x is equal to 64. And we can see that we have a quadratic function here again. And so we need, in order to solve this, this one's going to be able to be factored. We need to get 0 on one side. And so we'll subtract 64 from both sides. And then we get x squared plus 12x minus 64 is equal to 0. And then we can factor this. We need an x and an x. And the two numbers need to add to 12, but they need to multiply to a negative. So we need a plus and a minus. The plus needs to be bigger. So we're going to go 16 times 4. And then we can check to see the zero product property here. So x must be equal to negative 16, or x must be equal to positive 4. So we need to check both of those values to see which one works. And so we can check negative 16 here first. And so we'll just substitute the values in. Log base 4 of negative 16 plus 12 plus log base 4 of negative 16. I wrote over the line there. And already this one won't work, but we can log base 4 of negative 4 plus log base 4 of negative 16. That's equal to 3. Eventually, this will end up equaling positive 64. And it will look like it works, but we already log base 4 of negative 4 and log base 4 of negative 16 are undefined, so we can't use that. So we can check our other value of positive 4. So log base 4 of 4 plus 12 plus log base 4 of 4 is equal to 3. So what we get is log base 4 of 16 plus log, we'll just leave that as log base 4 of 4. And that is equal to 3. And we think about this, 4 to what power equals 16? So that's going to be equal to x is equal to 2. So this one right here is 2, and 4 to the 4th, that's equal to 1. So 2 plus 1 is equal to 3. So that one does work. X is equal to 4 works. X is equal to negative 16 does not work. So then we have the next example here. And we have, first thing we have to do is get the log by itself. So we can multiply both sides by negative 1, or divide both sides by negative 1. So divide by negative 1, divide by negative 1, and we get log base 5 of 9x is equal to 0, because we're dividing by negative 1. And now we can exponentiate both sides of the equation because we have the log 5 here and we don't have anything on the right side. So 5 log base 5 of 9x is equal to 5 to the 0 power. Anything to the 0 power is 1, and 5 to the log base 5 is 1. So then we get 9x is equal to 1. Divide by 9, and we get x is equal to 1/9. And then we can check that just to make sure that we're all set. And we're going to just substitute it in. So negative log base 5 of 9 times 1/9 is equal to 0. And that's what we want to check. So 9 to the 1/9 is 1. So we have negative log base 5 to the 1 is equal to 0. And if we're thinking about this, 5 to the 0 is equal to 1. And so that does work.